All right, matrix algebra 4.6. We're doing inverse matrices, finding the inverse of a matrix. Look at what we did in the previous lesson. We had a matrix, multiplied it by the identity matrix, and the result would be our original matrix. We could call our original matrix A. So that's matrix A. The inverse matrix we could call I. Inverse, I mean identity. I hope I said identity last time. And the result is matrix A. Right? When we look at real numbers, this actually looks a lot like, behaves a lot like normal numbers, right? A number like 3 times the identity matrix, and we can sort of see the identity matrix as like multiplying by the identity matrix is kind of like multiplying by 1, right? 3 times 1 is 3. A times I is A, right? It's true with real numbers as well, which helps us to visualize the next thing that I want to tell you. Like, what if we have a matrix, the same matrix A, and we want to multiply it by something, by another matrix, and we want our result to be the identity matrix. With regular numbers, and the A in this case will stand for 3, 3 times something equals the identity matrix 1. 3 times something equals 1. What do we multiply 3 with to get 1? Well, the inverse of our number, right? Any number multiplied by its inverse equals 1. Let's do a couple. 4 times the inverse of 4 is 1/4. That equals 1. Is it true for, like, if we start with a fraction, a fifth, times, what's the inverse of 1/5 is 5. That is 1. What if it was negative? Negative 2 times its inverse. The inverse of negative 2 is 1 over negative 2. That equals 1 as well. So it's true with all numbers. We are going to do the same with matrices. If we have a matrix and we multiply it by its inverse, our result will be the identity matrix, which was 1, 0, 0, 1, right? And the way we write the inverse of matrix A is this. Yes, you just have to remember, this is a 1. You just have to remember A to the power of -1 means the inverse of matrix A. Yes? Yes. Okay, I'm going to show you how to find the inverse of a matrix. Say this is our matrix A. 3, 5, 4, 2. We take these 4 steps to find the inverse of A, the inverse matrix of A. Okay, step 1 is to find the determinant. We did that in the last lesson. Let me find it. The determinant was this. So hope this fits. Yes. The determinant of A equals A times D, this term times that term, 3 times 2 is 6, minus the other terms multiplied, minus 20. Of course I had to get like a negative one. The determinant of this matrix is negative 14. Okay. We keep that information until step 4, where we use it. Okay, that was step 1. Then what do? We switch the numbers on the leading diagonal, and I want to tell you the leading diagonal is this one. We start with our, on the top left corner, and then the leading diagonal goes down like that. That's the leading diagonal. We switch the numbers on this diagonal. So we switch the 3 and the 2. So we get 2 here, 3 here. 5 and 4 are still there. Okay. I know, it looks weird. It's magic. Step 3, change the signs on the numbers on the other diagonal. This was our leading diagonal. This is our other diagonal. So the 4 and the 5, what do we do with them? We change their signs. These are both positive numbers. So when we change their signs, a positive becomes a negative. This positive also becomes a negative. Okay. Almost done. Step 4, what do? We divide this whole matrix by the determinant. The determinant was negative 14. So what we do is divide by the determinant. So dividing is actually multiplying by its inverse, right? This would be dividing by the determinant. I'm multiplying by its inverse. This was the determinant, negative 14. 1 over negative 14 times that. And then we just do that for each term. Goodness, why'd I have to pick a hard one like that? So the inverse of A equals 2 divided by, I'm just going to keep them fractions, right? You get the idea. 2 divided by negative 14, negative 5 divided by negative 14, which gives 5 over 14. Negative 4 divided by negative 14, which gives 4 over 14. 3 divided by negative 14, that's going to give a negative 3 over 14. And of course, you can simplify some of these fractions, right? This would be our inverse. If we want to write that as a formula, then we would say if matrix A is this, and we put our letters in, right? A, B, C, D, then the inverse of A equals, here, 1 divided by the determinant, 1 divided by the determinant of A, right? Times this matrix with these two numbers switched. So I'm going to put D here and A here, right? Switch the numbers on the leading diagonal and change the signs on the other diagonal so that B and the C stay where they are, except they get a different sign. Negative B, negative C. And this gives us our inverse matrix of A. There's a couple situations. Okay, some matrices are not going to have an inverse matrix because we are dividing by the determinant. Imagine our determinant being 0. That would mean the matrix has no inverse matrix because you can't divide by 0, right? And such a matrix that doesn't have an inverse is called a singular matrix. Singular matrix. That's nice for your notes. Has no inverse. And you can add because its determinant equals 0. Yeah, and you can't divide by 0. And in order to find an inverse matrix, you need to divide by the determinant. So if the determinant is 0, that's not going to work. You'll get an error. And that's called a singular matrix. All right, that's all.